Welcome to chemistry. Today we are going to learn how to calculate percent error. And to do that, we need to understand what is measured and accepted value. Why do we need this? So sometimes, especially during lab, we are going to be doing a lot of experiments. And when we do experiments, not all the time we're going to get accurate result. And when we don't get proper result that we are expecting, we should always do percent error calculation to figure out how far we are from the true or accepted value. For example, if I'm conducting a lab experiment where all of my students are doing the same exact lab in different groups, I can do a percent error calculation and figure out how far they are from each other. So the best result, I can compare my best result with other students' result to see how far they are from the accurate or true value. So in lab, this is a very common procedure. The percent error formula is given in your reference table. So if you're taking Regents chemistry, they will give you a reference table, and in that reference table, the very last page, reference table T, gives you all the formula. If you're taking chemistry at college level or anywhere outside the United States, most probably you're not going to get a reference table. So it's better if you memorize it, but if you are taking Regents exam, especially in New York City, the reference table is given and you can use that to calculate percent error calculation. What is percent error? It's the percent error measured based on the experimental value known as measured value. You have to subtract that from the accepted value, which is also known as true value. And then you have to divide that number by the accepted value. And since it's percent means out of 100, you have to multiply it by 100. So sometimes we calculate percent error with an absolute value. Instead of getting a negative percent error, we just take absolute value. And sometimes we don't do that. So if you're not taking absolute value of a percent error calculation, you might get something negative. Just keep that in mind. Now, what is measured value? Measured value is the value that we obtain by doing an experiment or measurement. This is also known as experimental value. Suppose a student is doing a laboratory experiment and calculated a mass, let's just say 5 grams, right? So the student weighted the mass and got 5 grams. So that's the measured value because the student conducted an experiment and got a result. So we can call it experimental value or measured value. Accepted value, also known as true or theoretical value. Suppose I precisely calculated and accurately calculated the mass of an object to be 5.005 grams. And colleagues of mine, other teachers, or let's just say other scientists, measured the same exact object and they also got the same exact number. So we'll consider that as a true value or accepted value, meaning something is accepted worldwide or by other scientists or people who we recognize as, recognize as someone who have better idea about it. And then measured would be something that other people are doing, right? So when you do something and when you're doing an experiment, you will get the measured value, and then in a textbook or in somewhere else, you might find the true value which should be given. Let's see how we can use this information to solve a question. In this question, the accepted value for the percent by mass of water in a hydrate is 36.0%. In a laboratory activity, a student determined the percent by mass of water in the hydrate to be 37.8%. They're asking you to figure out the percent error from the student's measured value. So if you are, if English is not your first language, um, it's always a good idea to focus on the number. And this is what I do. English is not my first language, so I always focus on the numbers, and that guides me towards the right track. What do I mean by that? For example, the first thing I would do is like I would highlight or underline 36.0%. When you underline or highlight a number, try to look next to that number, right? Try to look around. Next to that number, I realized that I have accepted value. So this 36% is my accepted value. Then I can highlight another number, which is 37.8%. So obviously use your logical reasoning. If the first number is accepted value and you're doing a percent error calculation, because everywhere you can see percent error, right? The word percent and the word error. So obviously that 37.8 has to be your measured value. And I'm looking at the sentence and I don't see the word measured. So accept this part, right? So again, use your logical reasoning to figure out what is the value, right? Is it accepted or is it measured? And that would guide you towards the right track. So what is the percent error? So the moment I notice the word percent error, I know that I have to use the formula. And as I said before in my other videos, I always prefer to write down the formula before I start solving it. I understand some of you might be, you might have excellent skills in terms of solving a mathematical equation, but if you don't, you should always follow steps. Even if you have excellent mathematical skills, you should still follow steps because for some reason, if you make an calculation error, it is easy for you to track it down. And during your exam time, you go under a lot of stress. So it's better to keep things organized so that we can find our mistakes right away. So I usually write down the formula, and then on the right side, I try to figure out what is given in the question. So what is given, right? I always write it down for visual purpose. If things are in front of my eyes, then I don't have to think about it too much. So I know that accepted value is 36%. And then I have another value, which is 37.8%. I also know that I'm using the formula for percent error. So, as I said before, if you did not understand the question and English is not your first language, it's okay. We can still use logical reasoning to guide ourselves towards the right track. And that should be your strongest technique. So, since I know that in that percent error formula, I have accepted value and measured value, and in my given part, I only see accepted value. So obviously 37.8 has to be your measured value. And percent error is your question mark, it's your unknown. Remember, you cannot solve for two unknown at the same time at this point, so just make sure you keep things organized. For my next step, I'm going to replace the numbers, replace the letters or values, right? And for example, measured value would be 37.8 minus accepted value would be 36 over accepted values, again 36. Some people use absolute value for this, which is okay. If you don't use absolute value, you're going to get a negative percent error. So you might get negative percent error, which is also fine. Don't get scared if you see a negative number. Now, once you're done, you can calculate this. One thing I would like you to notice is something that students uh, make that kind of mistake during Regents exam. If you notice my formula, I forgot to multiply by 100. And that's a major mistake during Regents exam. So don't do that. So make sure you're copying the formula from reference table T as it is. I've seen many students wrote down the right formula, did the correct calculation, but forgot to multiply it by 100, and that's why their answers are wrong, right? So please don't do that. Copy the formula exactly as it is, write down your given, and then just replace the letters or numbers, replace the term with your values, and then carefully calculate. And therefore, I got 5% error, right? So the student, what is the percent error for the student measured value? 5%, right? So it's just 5%, especially during a lab. It's not a big deal. Actually, it's good. A good result for the experiment. Let's try one more. This time, if you got what I said before, if you got the idea, you should try it by yourself. If you did not, we'll go through step by step. So for the people who got it, pause the video, solve it, and then play the video again to check your final answer. So again, focus on what I'm doing. I always read the last sentence first. That's a test-taking skill. Why? Because based on the last sentence, I know that I have to use percent error formula. So I'm going to write it down first. Percent equals measured value minus accepted value over accepted value multiplied by 100. So I know this is the formula I'm working with. Then I'm going to highlight the numbers. Again, as I said before, doesn't matter if English is your first language or second language, you should always learn how to take a test. You should always learn test taking skills. It might be beneficial for you. So I know that I always focus on the numbers. Here I have 55.01%. And then I'm thinking, okay, this 55.101%, is it my accepted value or is it my measured value? Because those two are needed to solve this question. So I'm looking left and right? I'm looking both sides, and I realize that in that sentence, they mention accepted value. So my accepted value is 55.01%, right? And then obviously, if that's the accepted value, 56.7% must be my measured value. Some students usually get confused, like, oh, what is 56.7%? You have to use your logical reasoning. If one of them is accepted, the other one has to be measured, even if the word is not in the question. So since the student did a laboratory activity, obviously the student did the experiment, and that must be the measured value, or sometimes it is known as experimental value, because the student obtained the number by doing an experiment. So let's calculate this. Let's replace MV minus AV with the numbers that we have. So MV is 55.01 minus, sorry, my mistake. So based on my calculation, I got 3.07%. Again, I always take the absolute value. In Regents exam, you can always take the absolute value. Or even if you don't take it and you have a negative percent error, still the answers are fine. But just double check with your instructor and double check with your exam procedure so that you don't get things wrong. So usually when we calculate percent error, it's very simple and straightforward. The idea is you need to figure out what is your measured value and what is your accepted value. Do not forget to multiply everything by 100 because it's percent, and percent means out of 100. So students, I hope you have learned percent error calculation, and thank you.